Okay, so moving on to cosine. So for cosine, our acronym is going to be CAH. C is for cosine. So cosine of theta, our angle here, which I've drawn our triangle again. I'm going to keep our example angle at 30 degrees here. So our cosine of our theta, our cosine of 30 degrees is going to be our adjacent over our hypotenuse, our A over our H. And in this diagram here, this is going to be our adjacent side, and our hypotenuse is going to be the same right there. So you have, wrong one, my bad, that's going to be green. Your adjacent over your hypotenuse, your green over your red. And again, your hypotenuse is always going to be across the triangle from where your right angle is. Okay, so looking at our first problem here, cosine of 60. So when we draw that out, this is kind of, you know, a straightforward one because 60 degrees is a value that's usually on our circle. So we know that's going to be in this upper right quadrant of our unit circle, so we can draw our triangle in there. We know that this angle is going to be our 60-degree angle, and we know our right angle is going to be here. Okay, so for our side lengths, I know I did kind of a poor job explaining this in the last video, but we're going to have that same trend that we saw in the last video with our triangles that are 30, 60, 90 triangles. If you remember back, I think you learned it in geometry, your special right triangles where you have your 30, 60, 90 triangles and then your 45-degree right triangles. And those always have special side lengths that are in a certain ratio. So the values that we're seeing here are kind of throwing us back to where you learned those ratios, where one side is 1, another side is 2, and another is square root 3. So those aren't just kind of random. Those are your special triangles from geometry. Again, you have your 30, 60, 90 triangles and then your 45-degree triangles. So if you go back to the sine video, that second problem was an example of the 45-degree special triangles from geometry. But we'll also see one in this video too. So that's our down in our third problem here is going to be a 45-degree special right triangle. So working back on this one, so we have a 30, 60, 90 triangle here. Our 90 is our right angle, our 60 is our theta here at the center, and our 30-degree is right up here. So looking at our ratios for our special 30, 60, 90 triangles, the value across from 60 here is going to be our 1. Down here across from our 30 is going to be our square root 3. And across from our 90, we have a value of 2. So looking here, so we're working with cosine here. And so we can label our sides. So our theta, again, 60, that's what was given to us in the problem, theta of 60. So our adjacent side to 60 is going to be down here. And our hypotenuse side is always going to be across from our right angle right there. And you'll notice all of our values are positive here because we're working in the quadrant where our x values are positive here and our y values are also positive, so everything's positive, makes it that easy. So working with our equation here, cosine 60 is going to be adjacent over hypotenuse, or our green over our red. So cosine 60 adjacent, over here we see our value is square root 3, and hypotenuse, our value is 2. So again, we have no square roots in the denominator, just in the numerator, which is fine. Everything checks out here. So that's going to be our final answer there, square root 3 over 2. Moving on to our next problem here, cosine 11 pi over 6. So this is the first time that we've kind of seen pi thrown into the mix. So we know our unit circle, other than 30, 60, 90, all of those values have their values that go with them. So for here, so we're doing with 11 pi over 6. So when we draw this out, usually you'd have your 3 here. This is going to be your pi over 6, your 30 degrees. This would be pi over 4, your 45 degrees. This would be pi over 3, and that's going to be your 60 degrees. We know that this one is 0 or 2 pi. And we know that this one is pi over 2. Our 90 degrees is pi over 2. Our 180 is pi. Or negative pi, but we'll leave that at pi. And then down here is 3 pi over 2 for our 270 degrees line. So we're working with 11 pi over 6. So this just kind of comes down to, do you have your unit circle memorized, I suppose? When you're taking an exam, I always like to just have it memorized, and right off the bat when I would get my exam, I would draw it out. I'd write out all my values that I knew for my angle measures, just so it was there. So when you're looking at 11 pi over 6, there's kind of a trick to remember where an angle is. So if you look at this, you'll notice that the numerator is 11, denominator is 6. Numerator, in this case, is twice the denominator minus 1, which is kind of a trick that goes along with this quadrant here when you're looking at values. So 2 times 6 would be 12, minus 1 is 11, and that's kind of the trend that goes along with values here. So you have 11 pi over 6 is a value down there. You also have 7 pi over 4 is a value down there. So 2 times 4 would be 8, minus 1 is 7, so that's where you get your numerator-denominator combo for that one. Another value down there is 5 pi over 3 in this quadrant if you're looking at your unit circle. And so that would be 2 times 3 is 6, minus 1 is 5. That's where you get your numerator-denominator combo there. But we're dealing with 11 pi over 6, but because we can recognize that trend, we know that that is in this quadrant. So we can draw in our line here. When you're looking to see, what are the values, like what would be the angle measure for 11 pi over 6, you kind of have to refer back to your original angles up here. And you notice that it has the same denominator as the pi over 6 value up here, which is equal to your 30 degrees up here. So because it has the same denominator, you can kind of see that it's gonna be 30 degrees right here from this angle down. So it's just kind of finding what's my base angle for the denominator that I have. Say if it was if we were given 7 pi over 4, you would say, oh, that has the same denominator as pi over 4. I know that pi over 4 is 45 degrees, so 7 pi over 4 would be your middle line down here. You have 30, and you have your 45, and your 60. And so this would be 7 pi over 4, and this would be like, the third angle down there is 5 pi over 3. So you know that, oh, it's a 3 in the denominator. I look up here, what's my reference angle up here? It's 60 degrees for pi over 3. So you know that this is going to be an angle of 60 degrees away from your line here, your baseline. Same thing goes for these. It would be 30, 45, 60, and 30, 45, 60, depending on what the denominator is for your reference angle. So anyway, off that tangent. So the triangle we're working with here, we know it's 30 degrees as our reference angle because we looked at the denominators. We know that this is 11 pi over 6 here. And so that's our reference angle, and our reference angle is 30. So we have 30 as our theta. We have our right angle here in this upper corner, and we have 60 degrees here. So you should have bells going off that it's another 30, 60, 90 triangle, like we identified before. So we know that it's going to be one of our special triangles with our certain ratio of side lengths. Label our opposite, or sorry, our adjacent and our hypotenuse here. Adjacent, again, is going to be adjacent to your reference angle. So even though this is kind of flipped around, your reference angle is, your adjacent side next to your theta angle is going to be right here. And your opposite end is going to be always across the triangle. And your hypotenuse is across from your 90 degrees. So we have our adjacent and our hypotenuse here. So when we go and look at what our side values are, our special triangles across from 90 is going to be 2 special right triangles. Across from 90 is 2. Across from the 60, square root 3. And across from the 30 degree is 1. But in this case, it's -1. But that's our only negative because in the x-axis, we're still positive. It's in the y-axis that we're now negative. So it's going to be -1. So when we look at cosine, 11 pi over 6, which we now know is really like 30 degrees is what we're working with. But like this angle is where the 11 pi over 6 comes in. If we were to stretch all the way around there, that's where that 11 pi over 6 angle measure would come in. But we're working with just our 30 degree because we already figured out that 11 pi over 6 has a reference angle of pi over 6, which is 30, and we're cruising along there. So cosine of 11 pi over 6 is going to be adjacent over hypotenuse. So that's going to be green over our red, and our green value is square root 3, and our red value is 2. So that actually comes out to be the same value as we had up here, which is square root 3 over 2. So now, looking at our third problem, cosine 225 degrees. So we're back in degrees. So we're going to draw our unit circle here. Apologize for my horrible circle drawing skills. And so 225. So this is kind of the same problem that we had, or a situation, not a problem, we can handle it. It's a situation that we had with our sine issue questions, where we're working with 225. So we're going to label what we know. So we know that this line is 0 or 360. This is 90. This is 180, 270. And so 225, we know that's going to be somewhere, again, adding up between 180 and 270. So that's going to be in this quadrant down here. 225. If you do some mental math, we know that if you add 45 degrees to 180, you get to 225. So that means that this value is going to be 45. So like I was saying, this is another one of our special right triangles here, because it's a 45 degree triangle. So that means this angle is also going to be 45 to get us to 180 for the degrees for the total triangle. So across from the 90 degree angle in a 45, 45, 90 triangle, you're going to have square root 2. And then these are both going to be 1, which makes sense because the angles across from them are equal. So their side lengths would be equal. But we have to remember that we're in the negative side of the x-axis here, and also the negative side of the y-axis here. So these are both going to be -1. And can label our adjacent and our hypotenuse sides, our red and our green. Go back to our equation. Cosine 225 degrees is equal to adjacent over hypotenuse, green over red. Cosine 225 degrees. Our adjacent value, -1, over our hypotenuse value, -2. And as soon as you see that square root in the denominator, you should be thinking about rationalizing to get that square root out of there. So if you remember, what we're going to do here is multiply by the value of that square root as 1. So put that value in the numerator and the denominator. This fraction is equal to 1, so you're really just multiplying this your original answer by 1, but how you're formatting that is going to allow you to get rid of your square root. So again, you have square root 2 times square root 2 for your denominators down here, and the square of the 2 will cancel out the square root, so you'll end up with just 2 in your denominator. Up on top here, you have -1 times square root 2, so you have negative square root 2, and that'll be your final answer for a cosine of 225.